This session is part of the final lesson of the P9 topic, P9.4, and it's all about a new equation that we can use to find unknown values such as final velocity, initial velocity, acceleration, or distance travelled, or displacement. So first of all, this equation, the reason that we have this equation is that we can use it if we do not get given a time value in our question. So to use, if we do not get given time in the question. Clue is in the name, but we only use this equation if we have constant acceleration. So for example, if we have a look at a velocity time graph that is a straight diagonal line, then we can use the constant acceleration equation for a journey such as this, even though of course we wouldn't really need to because we would be given a time value. If we have a journey with a velocity time graph where we have a curve, then we wouldn't be able to use this as that is not a constant acceleration. So the equation itself, it is quite complex, but don't worry, you do not need to memorize this one. So the equation is that the final velocity squared subtract the initial velocity squared is equal to 2 multiplied by the acceleration multiplied by displacement or distance. In symbols, that's v squared for final velocity minus u squared for initial velocity is equal to 2 times a for acceleration times s. Now, if you forget that an s is representing displacement, all you need to do is look at this equation on your data sheet. So you do get given this in an exam, and in an exam question, it would usually tell you to use an equation from the physics equation sheet. So that gives you an indication that you need to find this equation. It tells you what it is in words, and it tells you what it is in symbols. So an S is what we do actually represent the vector version of distance, which is displacement. Now in questions, it may be that they don't explicitly tell you what the final velocity is, or the initial velocity is, or the acceleration. Sometimes they will hint at what they are in the question in terms of words. I'll make that clear in just a moment. So for example, objects falling down. Objects falling down will always have an acceleration due to gravity of 9.8 meters per second squared, okay, or rounded to 10 meters per second squared. Again, they should tell you in the question, but just in case they don't, always 10 meters per second squared for an object falling down or accelerating due to gravity. An object falling down also will start with 0 velocity. So the initial velocity will always be 0 because it's being dropped from a certain height. It starts off being stationary in your hand or wherever it's falling from, and then will hit the floor at a certain velocity. In the opposite way, objects that are thrown upwards, they will be decelerating as they are thrown upwards, and so their acceleration will be minus 9.8 meters per second squared, or minus 10 meters per second squared. If you throw something upwards, it actually comes to rest right at the top of its flight before coming back down. So right at the top of its flight, it comes to rest, and so its final velocity at the top, I'm going to put that at the top, is 0 meters per second. You may also be told in a question that an object starts at rest. Or from a standstill. Then you know that their initial velocity u is 0 meters per second. This one's a firm favourite actually at GCSE, that they will say an object is not moving or it starts at rest, in which case you have to recognise that u is 0 meters per second. So just two little diagrams just to make us really think about these objects being thrown up or falling down. So let's imagine that we throw a ball upwards. We will throw it with a certain speed, which you may have to work out, or you may be told what it is. We know that the acceleration will be minus 9.8 meters per second squared because it's being thrown upwards. And we will know that right at the top of its flight here, it will have a final velocity of 0 meters per second. For an object being dropped, let's imagine, for example, we're stood on a cliff and we are dropping a ball down here. It starts with an initial velocity of 0 meters per second because it's stationary to start with. And because it is falling down, we will have an acceleration of 9.8 meters per second squared. So we can now use all of this information to have a go at the questions in the booklet. It may be that we need to rearrange this equation, which can seem quite complicated to start with. Make sure that you always substitute values in exactly where they are supposed to be. Make it simple for yourself. So say, for example, if you need to find the velocity, the final velocity on this side, you can do 2 times the acceleration times the distance. You can do this part and make that simple. If you want to get rid of your u squared from this side of the equation, because you have a subtraction here, you would then need to add it onto this side. So remember BIDMAS or BODMAS, however you are taught it in maths, you do your multiplication first and then you can add your u squared to this side. And finally, to get rid of a square value, you would have to then square root everything that was on that side.